Okay, the next part of this first lesson is to talk about recursive sequences. So here we're going to be talking about just the arithmetic and geometric, but we'll kind of paint the idea of what a recursive sequence is. So Fibonacci sequence is a recursive sequence. So how could we describe how to create the sequence? So you can think about this for a second. What's the pattern that's happening, and how does the sequence get created? So if we add the previous two terms to get the next term, and start with 1 and 1. And both of those points have to be part of a recursive sequence. A recursive sequence is going to use the previous terms in some way. And so here we're going to add, to get 2, we do 1 plus 1. To get 3, we do 1 plus 2. To get 5, we do 2 plus 3. But we have to have a starting point, because you could do the same pattern, but start with 3 and 3 or 5 and 10. So you have to have a starting point. So in general, a recursive sequence, the terms depend on one or more of the previous terms. So some really key notation here is that Tn is any term, just like in the general term formula. Tn minus 1 is the term before, and Tn minus 2 is the term 2 before. And notice that it's really helpful if you don't actually sub in n, but you just really understand that Tn minus 1, the notation, means the term before. So Fibonacci sequence would be represented like this. T1 is 1, T2 is 1, we have to say that. And then Tn is the sum of the two terms before, Tn minus 1 plus Tn minus 2. So if we add up those two terms, we get Tn. So now we can create it by doing 1, 1, and then take the two guys. So term 3 would be term 2 plus term 1, so it's 2. Term 4 would be term 3 plus term 2. Term 5 would be term 4 plus term 3, and so on and so on. So if we had this formula here, we could write out the equation. And so this one's not going to be arithmetic or geometric, really. But you can read the formula and see what it means. So what this basically is saying is we're going to start at term 1 is 2. And then term n, so any term, is 3 times the term before it plus 5. So we'll start out with 2. We're going to go 3 times the term before it, so 3 times 2, which is 6, plus 5. And then 3 times the term before that, which is 3 times 11, plus 5. Then we're going to go 3 times the term before to get the next one. We're going to 3 times 38, plus 5, and so on and so on. These are really helpful formulas for spreadsheets. Although the general term is way better, because if we want to find the 100th term, it'd be really hard to do that. But and it'd be a really big number. But if you want to find, you'd need all the terms before for a recursive. If you have a spreadsheet, you can just kind of program the computer, the spreadsheet to give the term before, and then just copy down. So it is actually like a useful type formula, although it does require this recursive formulating, like this recursive creation of the formula. So some sequences we can look at, 1, 3, 5, 7. We start with term 1 is 1, and then notice the pattern first. Means we're adding 2 to the term before it, so the term n would be the term before plus 2. This is called an arithmetic sequence. In general, and you don't have to remember this as a formula, T1 is the first term, and Tn is the term before the term that you're looking at plus the common difference. For geometric, T1 is 1, and here we're going to be doubling every time. So Tn is 2 times the term before. And in general, geometric sequences, that's what this is term 1 is a, and term n is r times Tn minus 1. And there's some properties.